Hey, hello everybody, it's Stereo Police, and welcome to my review of the Akitika GT-108 Stereo Power Amplifier. Just received it a few days ago, and I want to do a formal review. I haven't done a formal review of a product in quite some time, so what I thought I would do is divide this review up into three different discrete sections. They're all very different, and it would save me a little time, so I can do each of these on a different day. The three sections, parts 1 through 3. The first part that I'll do today will be a discussion of the product in general, what makes the company special, what I think makes the product special. Number 2, I'm going to describe, in a different video, I'm going to describe its operation, and I'm going to describe its sound in my own words. And then part 3, I'm going to give you actual sound samples. We're going to compare various songs played through the Akitika and compare them through Yamaha, Luxman, maybe a tube amplifier. I haven't decided yet, but that's how we're going to handle it. Today we're going to talk about part 1 and the discussion of the product as well as the company and what I believe makes this product special. I want to commend this product to you right off the bat. I think it's a special product. I think it's a high value product. I think it takes a lot for me to recommend something to my subscribers and a group of strangers, stake my reputation on it. And I think this is an important product and that it is such an incredible bargain out there. And I'm going to tell you why. And I have a couple of suggestions and a couple of things I'd like to see change on it, a couple of critiques, and I'll discuss those along the way as well. All right, let's go right to the Akitika website and look at the quick look at the GT-108 stereo power amplifier. And there are two versions of this. There's the 108 and there's the 104. And I'm not quite sure why. They're essentially the same amp, but the 104 is geared towards those who are driving 4-ohm speakers, and the 108 is geared towards those who are driving 8-ohm speakers. And the website says optimized for, and I'm not quite sure why. Most amplifiers can handle whatever speaker is thrown at them, so I'm not sure what the optimization is on this. So I have Cornwall 3s. They're 8 ohms and they're an extremely easy load. So I chose the 108, but I'm not sure what the differences in design would be for the 104. The 108 came out. Now the Akitika started out its life in the year of 2010, according to the website. And there is a home page and an About Akitika section. And according to the homepage, they started out in 2010, and I remember seeing their little ads in the back of Stereophile magazine selling kits, and I never paid much of attention to it back then, although I've always been intrigued by kit building. And they sold the GT-102 power amp as a kit. Not sure if they sold it fully built back then. And they've been selling it for quite a while. They have a good reputation, and during COVID, when COVID hit, they couldn't get the necessary amplifier IC from Texas Instruments to build the 102. So the designer, Dan, and the owner of the company decided to, instead of ceasing production, he went out and redesigned the amplifier boards right here to be fully discrete and not reliant on an integrated circuit. And came out with the GT-104 and GT-108, fully discrete, which I rather appreciate. And the website says that this discrete version has some advantages. Better bandwidth, lower distortion than the original 102. Questions whether the improvements are audible. I happen to think they are. And it's a bit more complex to build. There are more parts in the discrete version, well, as there would be, because the IC, the integrated circuit amplifier, has a lot of the components actually built into the chip. Whereas the discrete version, a lot of those components would have to be soldered right to the board. So that's the story with the 108. And let me go back to the home page real quick and just say one of the things I think makes this company special and what gives me confidence in this product. First of all, it's American made, and it's been around since 2010. The company's been around since 2010. They have outstanding customer service, which is important to me. And not only that, the designer, Dan, and this is right on his website. I'm not trying to dox anybody. I wouldn't do that. But right on the website here, the manager, the designer, perhaps the owner, I don't know the gent, is by all accounts a very, very skilled engineer. I have a lot of and he's also a musician. So you couple a musician with an engineer, you already have someone, I have confidence in designing and building equipment that can reproduce sound. I think that's actually rather important. The website also says that Dan has 46 patents. I think he has more than that now, and I was just curious. That's pretty impressive to me. I'm in the intellectual property field. So I was just curious, what kinds of patents that he actually had. I actually took a look at a few of them. And I'll just show you around real quick. We'll take a look at it. All right. So I pulled a couple of them up here, and they're in the, again, there's over 50 of them. I only pulled a handful here, but they're rather impressive. Dan gets down to the component level, and he's solving problems in the telecommunications field, apparently. I didn't dig into them deeply, but this particular patent's for a line driver having a synthesized output impedance. You can see it's right down into the nuts and bolts here. This one here is for an improved analog echo canceller. This is pretty serious design stuff right here. Here we have reduced flux imbalance signal distortion in data communications. Here we have a method for controlling quiescent current of an amplifier. So he's into the amplifiers. Here we have a method for reducing intermodulation distortion. That's also a common theme in amplifiers as well, but as well as in communications. Intermodulation distortion. Here we have more controlling of quiescent current in amplifiers. Here we have quiescent current control for Class A/B output stages. So he's really an engineer that actually works in the field of amplifiers and has U.S. patents to prove it. Amplifier circuit method for canceling Miller capacitance. That's a well-known issue to be dealt with in electronics. It's an inherent Miller capacitance is something that's inherent to transistors. And this is the last one I pulled, but this is one of over 50 of them. And the point being is this is a skilled engineer. And if you want someone designing audio equipment, this is a person that actually works in the field and knows what he's doing. And that lends itself to the confidence that I have as a customer, knowing that I'm getting something that's not just a company that's using an off-the-shelf schematic and tweaking it here and there. I'm getting someone that actually knows what he's doing for real. And I think that's extremely important. And a musician at that, so that, when he builds the equipment and he actually listens to it, he knows what to listen for. And that's borne out in my own listening test. The amp is fantastic. All right, if we could take a quick look at the specifications for the GT-108, we look at they're about 50. It's about 50 watts per channel into 8 ohms. The bandwidth is about 5 hertz to about 100 kilohertz at the plus or minus 3 decibel points. It's got a very good damping factor at greater than 119. The damping factor is the number that ultimately tells you how well the amp can control your speakers, especially the woofer. Good signal to noise ratio, harmonic distortion 0.003%, 50 watts. That's at its spec power into 8 ohms. Clipping at 1% occurs at a bit more than 60. See, I like that he talks about the THD being at 0.003 at 50, but he also says where the clipping. That's one of the things I do. Is THD is spec'd out differently in different situations, but I actually want to know where clipping occurs, and that's actually spec'd out here. I like that. Intermodulation distortion's low. Input impedance is high enough to handle 51 kilo ohms. Anything you want to throw at it, that's respectable. Sensitivity is normal. There's a 120 volt operation, 240 volt operation. Idle power 22 watts. That's pretty low. And that's about it. Just normal, typical specs for a Class AB amplifier. And let's roll down and take a quick look at the schematic. Very, very quick. I do have a more detailed discussion of the schematic in one of my videos, but let's just quickly walk through the signal path. Signal comes in right here. It goes through one capacitor right here that blocks. It's a DC blocker. It will come into a differential amplifier right here, which will, it's a noise canceling amplifier. Cancels common mode noise on the input line. Also accepts this V out is the feedback signal from the output, which will be mixed in with the differential amplifier to provide some negative feedback, which will reduce distortion, increase stability of the amp, as well as increase the bandwidth. So the signal comes in right here, it gets amplified a little bit, and then the signal leaves right here and comes down to these transistors right here and this one right up here. They're bipolar junction. These will, and it does not go through any more capacitors right here. These will provide voltage gain, and then these will feed the drivers right here. No more capacitors. There's a driver there and a driver there, bipolar junction, and these drivers will drive the power MOSFETs right here and right there. And the power MOSFETs will operate in Class AB. They're biased by the biasing circuit right here. There's also a little control down here that adjusts the bias based on temperature. The output comes out, and there's one more capacitor in the output path right there. So there's only two capacitors in the signal path. There's one more capacitor right there, and we come on out here to the output relay, and we come out to your speaker binding posts. So I count two capacitors in the signal path, 1, 2, 3, 4, 5, 6 active devices in the signal path. So pretty simple amplifier, not too complicated, very, although this appears to be a custom design of Dan's. I can look at some of the stuff that's going on down here and right here, some of this protection circuitry out here. This is not an off-the-shelf schematic. Dan, being an outstanding engineer, clearly designed most of this on his own. I've seen lots of off-the-shelf schematics of Class AB amplifiers, and this is not one of them. So very good design, simple enough design, not a whole lot in the signal path to interfere with the sound, and that's about all I can say for that. All right, one more thing I want to add, a couple of notes here is, as I mentioned, what makes the company special is we have a known outstanding engineer at work. There's a lot of products you buy, you have no idea who designed it, no clue. They don't disclose their schematics. They keep things secret. They have a lot of proprietary terms, a lot of marketing lingo, And this is another thing I have, not a marketing company. A lot of companies out there, got a few big ones that come to mind, are marketing companies. A lot of hokey, nonsensical marketing with their fancy terminology, their fancy names, but they don't disclose their schematics. They don't really disclose much about what they're doing with the circuitry. That's all kept rather secretive and under wraps, and what they want to disclose to you is their marketing campaign. And that sucks a lot of people in. And that's what I like about Akitika. There's no fancy marketing campaign. They've got no gimmicks. They've got nothing to hide. They disclose their schematics. It's all go and no show. What you're paying for is an outstanding design and really good sound and no frills. And that's why you can get an amplifier that competes on par with my $9,000 retail Luxman for $600. No joke. This is what makes this company special and this product special. Also, they're true to kit form. It is awesome to build a kit. It's it's very, very special to actually build a kit and get it working and listen to it because you built it. And kits, for those of us who go back to Heathkit and some other companies back in the day, kits are woven into the fabric of audio. They really are, from back in the day. And it's really nice to still see that around. There are a couple of kit companies around, but Akitika is one of them, and it's just nice to see that. Also, with the 108, there are no integrated circuits in the signal path. It's all discrete quality components, which I appreciate. No ICs, no op amps, nothing. I think that's important. It's important to me, and that makes it special. Of course, the price makes it extra special. That lends itself to value. And I'm telling you just to speculate here, if you were to take the innards, the guts of this Akitika and put it into some high-value, fancy-looking case, enclosure, put some big name on it, and give it to a reviewer not knowing what's in it, with its marketing campaign and all that, and say, compare this to some of the best amps out there, I'm sure this would compete with just about anything. That's how good it is. So what I want to do now is I want to give you some visual comparisons of the GT-108 versus the 102. I have both of them here, real life, live, and also I want to take the 108 down to my bench and do some measurements. Let's check out. Let's just do a test. Check out where it clips. Let's check out the power it produces into my 8-ohm dummy loads before we reach 1% THD. Let's put a square wave into it, look at the output. Let's just make sure everything's on the up and up. I won't do too many tests, but let's just verify everything is in order. I mean, I've already listened to it. It sounds fantastic, but let's just run through this real quick. Also wanted to burn it in for a while on my dummy loads, but although I've been burning it in by doing some listening as well. So we'll do that, and then I'll come back and we'll give you some concluding remarks, some constructive critiques, and a suggestion for Akitika, for the company. Not that they care, but I'm so excited about a company like this. I'd love to see them actually do more, although I seriously doubt Dan has the time. All right, I'll be back. Let's just put this 108 on my bench and do a couple of tests real quick. All right, on your left, you're looking at the GT-108, fully discrete version of the GT-102 that you're looking at right here on the right. In the GT-102, the predecessor, here are the ICs, the integrated circuits. Forget the LM number, the Texas Instrument IC that the 102 uses. And
Each circuit board has its own separate heat sink in the 102. And bouncing over to the 108, you can see the circuit boards are larger, they're more populated with components, and both channels share a single heat sink. And the output devices are not integrated circuits. You can see that here are the output MOSFETs for each channel, left channel, right channel. And attached to this MOSFET, so that's a MOSFET directly attached to the circuit board, and then you can see there's a transistor attached to the front of it, and that transistor actually, I've seen that on the circuit board, that is a transistor that controls the bias current based on the heat or the temperature that it senses on this transistor. So it controls the bias to prevent any sort of thermal runaway. It maintains a stable bias based on temperature. The power supplies are roughly equivalent. They changed the color of the heat sink, and this heat sink here has definitely more fins than the 102. I don't know if there was a need for that, or it's just the supply chain that they've chosen. But the heat sinks, I mean, the power supplies are definitely different in just looking at them. I haven't studied the schematics closely, but you can see that the circuit boards are populated. This is the 102, and here's the 108. So the circuit boards are populated a little differently, and the layouts are different. So these designs between the 102 and the 108 are different. They're still both using the same toroidal transformer. They look roughly the same. They have a different hat on them, a different cap on them, but looks like the 108 has a higher quality cap. Not that that matters to anything related to sound. Also, I noted that on the 102 we have these discrete rectifier diodes right here, whereas in the 108 we have a rectifier device right here taking its place. So all four of those discrete rectifier diodes are in this one package right here. That doesn't matter to me whatsoever. I purchased the 108 completely built from Akitika, thank goodness, because look at the layout of these boards. This is tight. There's a lot of tight soldering that's got to be done in there, and not that it can't be done, but it would take quite a while for me to build, and I really didn't have time to do it, so I'm glad I purchased this. Alright, so there we have it, the 108 versus the 102. Externally, they are the same, except, of course, the Akitika 108 has a little sticker on there that says 108 that they put on top of the previous inked in 102. I guess they had an excess of these silk screened, I guess, container silk screened enclosures, and they wanted to use them for the 108, so they just simply put a little black sticker over it that says GT-108. Alright, let's get into some measurements of the 108. Check it out. Alright, I'm feeding the Akitika a 1 kilohertz signal from my audio signal generator into the line level inputs. I can control the amplitude here, and that's what you're seeing in the blue trace on the bottom is the input signal. I'll adjust the amplitude right now. Okay, and the top yellow trace comes from the dummy load. I've got both speaker binding posts connected each to its own 100 watt power resistor, 8 ohms, and I've got one probe of the scope, and we're looking at the right channel, and that's what you're seeing in yellow. So I'll take a look at the right channel first, and then we will then I'll take a look at the left channel on my own. Okay, so the first thing I want to do is I want to turn up the amplitude of the input and find out where clipping begins. And you're looking at a sine wave right now at 1 kilohertz. Clipping is when the top and the bottom, or both, of that sine wave becomes flat. And in vacuum tubes, typically clipping will be soft and slowly become flat, but in transistors, typically it's very hard. That flat top will happen quickly. So let's do it. Then I want to take a voltage reading right before clipping, and then I can square that voltage, divide it by 8 ohms, and determine the power at which is output right before clipping. So let's go ahead and do it. Keep an eye on that sine wave. And okay, see the clipping right there, top and bottom. I'm going to turn it down right before clipping. .3 volts. .3 volts RMS. So I'm going to take 21.3 times 21.3 divided by 8, and that means we have 57 watts available at 1 kilohertz right before clipping. 57 watts. So we're right on spec. And as you can see, the sine wave is nice and clean. I'm going to repeat the same for the next for the left channel. There's no need for you to watch that. Next thing I'm going to do is take total harmonic distortion measurement with my Keithley THD meter and find out where we're 1%, which is a standard for some people. And we'll determine at what power we see 1% start happening, and we'll take a look at the harmonics. So the second harmonics, third harmonics tend to be perceived as harsh, whereas even order harmonics like second and fourth, not so much. So let's take a look at that. Let me get that hooked up real quick. Okay, right now the sine wave you're seeing is roughly 5 volts RMS. So 5 times 5 is 25 divided by 8. So that's roughly 3 watts or so of power that's being dissipated by the dummy load, the resistor. I'm going to start to, well, what I want to do is I want to show you the THD. So right now we're seeing 0.014. Now that's not the THD of the GT-108. You're seeing the THD of my audio signal generator. That's about as good as it gets. That's the THD of the signal I'm feeding into it. So the GT-108 is actually lower than that, but that's the best I can do with the equipment I have. So that's the bottom floor right there. So I'm going to start turning up the amplitude until this THD starts to really climb and reach 1%. Now we're at 0.2%. Nope. I'm slowly turning it up. Now there we go, 0.4. And guess what? At 0.4%, I can see the top of the, you can't see it, but the top of the waveform is just starting to clip. So that, and let's go up to 1%. So that, and you can see, at 1%, we're seeing that clipping right there. And let's go take a look. There are the harmonics. So we have a second, third, fourth. Now let me turn the amplitude down. Watch those harmonics go away. That means the clipping is gone. So once again, let me, just knowing that, let me see, that's where the harmonics just to start to pop up. So that's where clipping is starting. So let me go down right there where the harmonics just disappear. Go back to our sine wave, check out the voltage, 21.3 volts. Is that the same thing we had before? Yep, that's 57 or 58. Very clean watts, and there is no distortion that slowly builds up before clipping. I mean, it's clean until clipping. Clean until clipping. There's no issues here, folks. Let me see if I can bounce over. Okay, I got a 1 kilohertz square wave. So this is, you're looking at the output of the amplifier, and look at that square wave response. This is the output of the amplifier. That is as good as it gets. A square wave response can tell you a lot about the frequency response of the amplifier and its ability to reproduce transients. And that is a clean 1K square wave response. That is clean. I didn't expect to see something that clean. When I was hooking up the amp, I accidentally had a short circuit on the output, unbeknownst to me, and you can see here, turn the light out, it's hard to see, but there are some little light LEDs glowing in there, and there's some relays. When the output was shorted, the protection circuit was kicking on. I heard those relays kick on and off, on and off. A couple of those LEDs blinked. I knew what I was hearing. I knew I was hearing protection circuitry, and I knew I had something wrong, and it worked like a champ. No issues whatsoever. It did what it was supposed to do. Perfect. Spot on. Great job, Akitika. Of course, they have a great engineer. I wouldn't expect anything other, but the build quality, I ordered this fully built. The soldering is as good as way better than I can do, and absolutely thrilled with this product. How they can build this and sell it for $600 is beyond me. 600 bucks, hell, that's a bad night at a nightclub, or a good night.
It's Stereo Police, all right, back with the conclusion of part 1 of my Akitika GT-108 review. This will be not my overall conclusions, but my conclusions just from the brief look around and a couple of critiques. So, number 1, I don't have any critiques other than that little sticker on the front. I showed you when I was bench testing the Akitika, they covered up the previous GT-102 silk screen or inked insignia with a little sticker, a little black sticker that says GT-108. I understand. I know why they have to do it. It's cost and that sort of thing, but it just looks so amateur and so DIY for such an incredible product. Everything about this product, as a consumer, for me, everything about this product that I just explained to you lends itself to quality, gives me a really good feeling about spending my money on this product. And that little sticker, I don't know why it shouldn't bother me, but it does. I don't like it. However, I completely understand.
The value of this product is through the roof, and if that keeps the cost down, that's fine. Though I'd be willing to pay a little more not to have that sticker. It just doesn't seem right. It seems not as professional as this product ought to be. But it's such a minor. If that's the only thing I have to complain about, and I'm not complaining, that is minor. Critique, constructive criticisms. Well, there have not been many products that I've ever purchased, and I'll get into the sound later, that is so flawless out of the box. Normally, I have something that I'm nitpicking about. Now, I'm putting all this into perspective relative to price, but even relative to price, there's very little that I'm wanting out of this product. So the only thing I actually want is I want more from this company. And, and I understand that Dan probably has a full-time career, and this company's, I'm guessing, I have no idea, I've never interviewed him. I'd love to interview the guy. Fascinating guy, I'm sure, but I don't want to bother him. But boy, I wish they'd make more products. I wish he would turn Akitika into more of a mainstream company and introduce more products, because I have such respect for his abilities, and these products sound so good, and the company ethos is just what they're about. They're about sound and not about flash, and not about silly marketing. Just goofy marketing stuff. Anyway, what I like to see from Akitika is a version of the 108 or 104 that's biased heavily into Class A for efficient speakers, such as horn-loaded speakers, such as folks like me that have Cornwall 3s. Forget the 4s. Don't go buy the 4s. 1s are probably good 2s, but have the 3s and other high-efficiency speakers. So I'd like a Class A amplifier with meters, with VU meters. Wouldn't that be nice? Just a wish. That's all. Wouldn't that be awesome? Hey, I'd love to see Dan build a DAC also. With his abilities, I'll bet you he could build one of the best DACs out there. But I seriously doubt he'd have the time to do that. But maybe in his retirement he can. A DAC. That would be great. Hey, an R2R ladder DAC. That's what I want to see Dan build. But the best one out there. Huh? So those are the only things I have to say, is I want more from this company. I'd love to see more. All right. That's about it. Boy, wouldn't you love to, I'd love to have a Class A low, like let's just say 5 watts, 10 watts a channel. That'd be about it, with a couple meters on there. So, and the meters would be functional, because when you have a low power amp, you kind of want to see when you're about ready to drive that amp into, into its 1% THD range. You want to know kind of when you're getting there. That would be nice. I really want that. I'd pay twice the price for that with meters. All right, Dan, if you ever hear, I don't even know if Dan knows I make these videos. But that's what I want. I am now not de facto, I don't know what the word is. I want to be the marketing director of Akitika. I'll do it free. I'd have a conflict of interest with my current employer, so I'll do it free of charge. All right. Stereo Police, I hope you enjoyed part 1, and I'll be back with part 2, listening impressions verbalized to you, and part 3 with real comparisons with other amps. I'll try to get everything done over the course of this weekend. It's Saturday right now. I spent a good chunk of my day doing this for you guys, my subscribers, and others who are interested in a high-value product. And I'll be getting to my review of the Macintosh C8 real soon, but I was so excited about this. thus far, if you can't wait to get to parts 2 and 3, I can tell you without a doubt, if you're interested in this product, pursue it. Stereo Police, I'll see you at part 2. Ciao.